the presentation is visible to you?
Yes, sir.
Thank you. So today's topic is about what are the advantages of database management systems. So before starting with the advantages, so we are having one more pending topic related to the last class, workers behind the scene. So if you take a database management system, various persons are associated with a database management system. You can categorize those persons into two categories. One is first category is called as actors on the scene, and second one is workers behind the scene. So your database administrator, database designer, end users, then system analyst. So these persons comes under the category called as actors on the scene. So actually they are responsible for day-to-day maintenance or a day-to-day successful execution of the data or successful maintenance of your database management system. So the other category is workers behind the scene. So in addition to those four persons, okay, so in addition to your database administrator, database designer, system analyst, and the end users, you are having another group of people associated with your associated with the design, development, and the operation of the database management system software and the system environment. So what is the difference is these people are responsible, or these people are associated with your these people are associated with your database management system software and not with your database itself. So actually what we can say is these are the persons who are not interested in the database or what is stored in the database. So these persons we are going to refer these persons as workers behind the scene. So again we can have based on the task. So what we can do is you can classify these persons into three types. So first category is called as database DBMS system designers and the implementers. So if you take a database management system, actually your database management system is a collection of various modules. So these persons are responsible for developing and implementing all these modules. So what are the various modules available inside your database management system? So for example, you are having a module for query processing, module for DBMS catalog, module for interface processing. So for buffering the data, concurrency control module, you are having a separate module for data recovery and security. So actually if you take a database management system, it is going to be a water. So it is considered as a very complex software containing various modules. So here I have listed some modules or few modules for your reference. So now, so what is the requirement is, so in some situation there may be a need to water. So there may be a need for this database management system to interact with the other software or other system software. In some situation they are interested, so these modules need to interact with your operating system or compiler, or in some cases with another programming languages. So for performing buffering, data buffering and all, your DBMS management system need to cooperate or need to interact with your operating system. So for creating a memory or for creating a temporary buffer. So in some situation there is a need for what, that your database management system need to interact with the other system softwares. So these personnel are responsible for what? These persons are responsible for developing and implementing all these modules. So second category is tool developers. So these persons are responsible for designing and implementing tools. So apart from your DBMS management system, so what you, in order to improve the performance of the database management system, what we can do is we can add some additional tools. So basically what is a tool? With respect to this scenario, a tool is nothing but a what? A tool is nothing but a software package that helps you in database modeling or that helps you in database design. So usually these tools may not be part of your original database management system. And again, these are not going to be the mandatory thing. Okay, so these are the optional packages. What you will do is, so usually these packages are developed by some third-party vendors. So in order to increase the performance, what you can do is you can purchase these tools and you can integrate with your database management system. Okay, so that is the second category called as tool developers. The third one is the operators and the maintenance personnel. So in other ways, we can refer these persons as the system administration personnel. Actually, these are the persons who are responsible for running and maintenance of the hardware and software for your database system. So these persons are responsible for providing an environment containing the proper maintenance of hardware and the software environment. So workers behind the scene, you can have three types of persons. So first category is database system designers, second one is the tool developers, and third one is going to be the operators and the maintenance person. So next idea is about the advantages of your database management system. So already we have discussed about the characteristics of your database approach. In addition to that, these are the additional advantages of your database management system. Or in short, what I can say is database system. So what is the first advantage? So controlling redundancy. If you take your traditional file processing, in the case of traditional file processing, each and every user or each and every group of user maintains a separate file, or for each and every group they are going to have their own file for storing the data or for handling the data related to that particular application. What they are going to have is they are going to have their own file. So the same, there is a chance for what? There is a chance for having the same data in more than one location. So your data is said to be what? In the case of traditional file processing system, your data is said to be redundant. Because of this redundancy, what is the problem you may face? So in certain scenario, there is a need to perform duplication of effort. You may be having duplication of effort. So already I have mentioned. Okay. So if the same information is available in more than one location, what you have to do, and if you want to add an information, you need to insert the data in multiple locations. If you want to perform an update, you need to perform an update in multiple locations. So that is the idea behind your duplication of effort. And since most of the data, so the thing is, so in each and every location you are going to have only few distinct data. Most of the data is going to be common in all the locations. So what is the major disadvantage? Because of that, the major disadvantage is wastage of storage space. So huge amount of storage space is wasted because of what? Because of this data redundancy. Now, another disadvantage in the case of file processing is, so now you may ask a question, sir, I can ensure that I can ensure the operation is successfully performed in more than one location. Suppose if I insert the data, I can ensure that the data is inserted in more than one location, or the data is updated in more than one location. Even if the same operation is repeated in more than one location, you cannot say that your data is going to be up to date or your data is going to be exactly same in all the location. Still, there is some chance for inconsistency. So one simple example is, so while performing the operation in some location, you may be having a typographical error. And in one location, your date of birth may be 23/9/1976, and in another location, it may be what 23/10/1976. So there is a chance for what? There is a chance for error. So this is a simple example for your typographical error. So now, what is the major advantage in your database system is your redundancy is controlled. Your database system has controlled redundancy. Why? Because you are going to collect all the data into a single repository and you are going to store all the data in a single location. So initially you will be having some redundancy. Once your database is normalized, your redundancy will be eliminated. So that is the third unit. So initially what we are going to have is, we are going to group all the data into a single location, or you collect it in the form of a repository, store it in a single location. So you will not have what? You will not have any wastage of storage space. And another thing is, there is no need to perform the there is no need to repeat the same operation more than once. So some data may be repeated, but it is somewhat limited. So redundant data is limited in the case of a database system. So that is the idea behind your controlling redundancy. So you are, with respect to your database system, you are having controlled redundancy. So second advantage is restricting unauthorized access. So now suppose, so what repeatedly what we are saying, so if you are going to create a database, we are going to have multiple users, or you are going to allow multiple users to share a large database. So now your database is going to have various information, and it is going to store various information. We don't want all the users to access all the information. So what we need is, we need to categorize the users. Suppose you may have some sensitive data inside the database, some financial data that is stored as part of your database. It is considered as sensitive, or it is considered as confidential. So you want to allow only authorized persons to access, or authorized person to modify that particular data. And in addition to that, what we need is, so we don't want all the users, or we don't want to provide all the users with the same privileges. So what I need is, I want certain group of users to only visualize the data. That is, they can perform only the read operation. They are not permitted to modify the data. So first thing is, you want to restrict some users from modifying the data. Okay, so that is the idea behind what? Restricting unauthorized access. So what is the requirement is, you need to identify the user, you need to group the users, and you need to have appropriate authorization mechanism. So what is the authorization mechanism you are going to have? So you are inside the database management system, we are having one subsystem called as security and authorization subsystem. So this subsystem will be used by your database administrator to create the various user accounts and to associate various restrictions or constraints to those accounts. So this, so again, this module, this authorization subsystem is going to be a what? Again, it is going to be a privileged module. So only the database administrator is allowed to access this particular software. So if, for example, if you are going to have the parametric users, so parametric users are allowed to what? So parametric users will perform the same operation repeatedly. So these parametric users are allowed to only access the database through some predefined apps or through some predefined canned transaction. So this is with respect to your restricting unauthorized access. So third advantage is providing persistent storage for programming object. So when your data is said to be persistent, so if you are going to store the data in the secondary storage device, then only the data is said to be persistent. So, so your database provide persistent storage for program object and data structure. So the thing is, so this is similar to what? Whenever you are going to store the variables in your primary memory or objects in your primary memory, those things will be discarded once the program gets terminated. So if you want to if you want to retain the data even after program termination, what is required is you need to store the data in the permanent files. Now, what they are trying to say is with the advanced database management system. So, what you can do is, so you can create a object in C++ and you can store it permanently in your secondary storage device using an object-oriented database management system. So, if you are going to store and if you are going to store an object in your secondary storage management, secondary storage device, then that particular object is said to be persistent. So, with respect to the recent database management system, that is object-oriented database management system, you don't have the impedance mismatch problem. Whereas if you are going to rely on the traditional database management system, you will be having impedance mismatch problem. So what do you mean by impedance mismatch problem? Okay. So the thing is, so inside a class, you are going to have a class. Inside the class, you will be having some data members and the methods. So directly you cannot store it in the secondary storage device. So you need to convert the data into a different format. And at the time of retrieval, again you need to retrieve according to the source format. So you are having a source and a target. So you cannot, so it is not possible for you to store the data as it is in the target. So you need to convert the data according to the target requirement. So this conversion will be automatically done by your object-oriented database management system. Whereas it is not possible in the case of for this type of conversion. So your traditional database management system won't perform this type of conversion. So because of that only we are saying with respect to the traditional database system, we will be having the impedance mismatch problem. So there is a mismatch between the data structure in the source and in the target. Okay. So that is the third advantage. So fourth one is providing storage structure and search techniques for efficient query processing. Okay. So basic thing is you are going to store the data in the secondary storage device, or what we can say is your data is stored in the disk. So so the thing is always there is a speed mismatch between your primary memory and the secondary memory. Whenever you execute a query, you want to retrieve the data in a lesser time. So what is required is, so for quick retrieval, your database management system need to provide some specialized data structure, and it needs to implement some specialized search technique in order to locate the desired records in a lesser time. So for a given database, what your database management system is going to do is, it is going to create some auxiliary files. We are going to refer these auxiliary files as an index. So for each and every record, you are going to have an index file. Or for a database, you are going for a table, you are going to have an index file. So for each and every record, you will be having one entry inside the index file. Again, how to implement this index? So for that, you are having various options. You can implement this index either using the tree data structure or using the hash data structure. So creating and maintaining this tree data structure and the hash data structure is the responsibility of your database administrator. And again, in order to increase the efficiency or in order to reduce the search time, see again you are creating an index file where the index file will be stored. The index file will also be stored in your secondary storage device. Then in that case, how to increase the speed for that? We are going to employ the concept of buffering or caching. So your DBMS need to coordinate with your OS to create a buffer or to create a cache memory. So part of your index file will be stored in your cache memory. So again, we are having various issues. So the size, if the size of the index file is larger than the size of the cache, you need to employ some appropriate cache replacement mechanism and all. So that we will discuss later. So in order to increase the speed, what we are going to do is part of your index file will be stored in this cache memory. So it is the responsibility of how to execute the query in an efficient manner. So The thing is, so these concepts, so the first 4 points are related to what? Providing storage structure. So these storage, you can use the storage structure for efficient query execution. So if you want to execute a query, what are the steps involved in executing a query? So actually this diagram summarizes the various steps involved in query processing. So this is the query what you are going to, or this is the input given by the user. See, suppose you assume that you are having a table called the student. I want to view all the content from the student table. So simple query will be what? Select star from student or select register number from student. If I want to retrieve only the register number from the student table. So simply what I can write a select register number from student. So next first thing is what are the various modules involved in query processing? You will be using the parser and the translator. So your query will be query in the high level language will be converted into the relational algebra expression. Then based on the statistical data, you will be using the optimizer and then you will generate the evaluation plan. So you can have, for evaluating a single query, you can have multiple evaluation plan, and you need to select the efficient evaluation plan, and based on that plan your query will be evaluated and the output will be fetched from your database and it will be displayed to the user. Okay. So with respect to query execution, what is the role of this parser and the translator? So your parser and the translator is responsible for translating the query into its internal form. That is, from the high level language, it will be converted into relational algebra. So parser will check for the syntax error. Then what is the role of the evaluation model? Evaluation module. So the query execution engine, that is your query evaluation engine, what it is going to do is, so it takes a query evaluation plan. So from the execution plan, it will take the query evaluation plan, execute the plan and return the answer to the, not to the query, return the answer to the users. Here you are having a typographical error, or return the answer of the query. Okay, so you can modify like that. Okay. Now, so the thing is, so what I have mentioned, for the same query, we can have more than one solution. So this is a simple example. So now I am having a relation called as instructor. So as of now, don't bother about this. Okay. So this is a simple example. So I am having a relation called as instructor. So from the instructor relation, I want to retrieve all the tuples or all those tuples which satisfy this particular condition. What is the condition? The salary grade less than 75,000. Or from the instructor relation, see, in the case of relational algebra, we will use the term relation. In the database, we will use the term as table. Or from the instructor table, I want to retrieve all the instructors who are getting less than 75,000. Okay. So now, so this is the, so thing is what? So which field I want to select? I want to select the salary field. And what is the condition? I am going to apply the condition salary lesser than 75,000. So the thing is, you are having two operators. So one is selector and another one is projector. So you can rewrite the same query as, first what you can do, you can first apply the condition, extract the relevant records, and then you can display those records. Both are same. Okay. So now what you can have is, okay, so you can evaluate this based on what are, you can evaluate this based on different algorithms. So you can have a what? You can have an index for the salary field. So based on the index, you can perform a search and you can retrieve the appropriate records. Or what you can do, you can perform a what? You can perform a complete search in the instructor table and then you can retrieve the appropriate records. These are the various options you have for identifying and retrieving the records. So now, the thing is, so here what we can say is, you are having two different options. Here also you are having two different options. Either I can go with an index or I can perform a complete scan. So among the available option, what you have to do is you have to identify the plan which incurs the minimal cost. So now you need some mechanism to measure the cost associated with the query execution. So what are the various parameters you can use for expressing the cost associated with that particular evaluation plan? So your cost depends upon various factors. So generally your cost is measured using the total elapsed time for answering the query. So this elapsed time is based on what? Disk access, CPU speed. Suppose if you are in some situation, if you are going to use network, then even it is based on your network communication also. So generally, if it is what we need to do is we need to incorporate or we need to consider the disk access. So for this disk access, what are the parameters you need to consider? How many number of seeks you are going to have, number of blocks read and the number of blocks written. So now based on these parameters, what you need to do is you need to identify the plan which incurs the minimal cost, and you need to use that plan for retrieving the relevant data from the table or for retrieving the relevant data from the given expression, given relation. That is with respect to your query valuation. Now, so next thing is clear. So fourth step is providing storage structures and search techniques for efficient query processing. So what is the storage structure you can use? You can use index. So you are going to create an index for the given database. In order to reduce the time, you can implement this index in the form of a tree or a hash. Now, ultimately, using the storage structure, we want to reduce the query processing time. So, what are the various steps involved in query processing? How to measure? What are the parameters that contribute to the cost, and how to identify the plan? So, the thing is, ultimately you need to identify the evaluation plan which incurs the minimal cost. So next advantage is providing backup and recovery services. Okay. So one module in your database management system is backup and recovery. So whenever you are going to have hardware failure or software failure, this module is responsible for what? This backup and recovery module is responsible, or these two modules are responsible for restoring the database to the consistent state or restoring the database to your safer state. So again, you can recall the same ATM example what I gave in the previous class. Okay. Suppose if you are going to have a failure in the middle of a complex update transaction, you cannot simply abort the transaction. So what you need to do is you need to perform undo operation so that your database will be moved to a state. So that state is equivalent to what? So before starting this particular transaction, so what is the database state? You are going to restore to that particular database state. In some situation, so the thing is, if you want to withstand catastrophic disk failure and all, so what you can have is, so in some situation you need to store the what? You need to take a backup of your entire database and you can keep it in the what? You can keep it in the magnetic tape. So nowadays it is very, very rare. Okay, we are having some other mechanics. Okay. So next advantage is providing multiple user interfaces. So for a given database, you are going to have multiple users. So we cannot assume that each user is going to have the same knowledge with respect to the database. The technical knowledge of the user may vary. So what is the requirement from your database management system is it needs to consider all the users and it needs to provide a variety of user interfaces according to the user requirement. Now suppose if I'm going to be a user and if I want to access the database from my mobile phone, what is my requirement is I need an app. I need a suitable app to access the database from my mobile phone. And for with respect to your casual users, your database management system must provide must provide support for what various query languages. So in the for application programmers, it needs to provide support for what various APIs. That is nothing but your programming language interface. So for parametric users, I can collect the data using some forms. And for other group of users, that is for standalone user, what I can do is I can go with the menu-driven interface. Or what I can do is, so I can collect the requirement in the form of a general English, that is your natural language, and I can construct a query based on the requirement. So you can have a menu. So select the table name, select the field name, select your operation like that. You can display a menu so that each and every user will make the appropriate selection. So based on the user selection, you can construct a query, and that query can be executed, and you can retrieve the answer, and you can display the answer to the user. So combinedly, this forms and menu-driven, menu-driven interface is commonly known as your graphical user interface. So what is the requirement is, depending upon the user need, your DBMS should provide various interfaces. The interface may be based on a form, or it may be a programming language, or it may be your API, or it may be your it may be an app, or it may be a menu. So these are the various types of interfaces provided by any database management system. Or these are the most common interfaces provided by almost all the database management systems. So next advantage is representing the complex relationships among the data. So the idea is, you have created a database. Now initially, based on the requirement, you have created a database. After some time, you want to add one more field to the existing database. If you are going to add an existing field, if you are going to add one more field, it is going to have a relationship with some other existing field or some other previous field that is available in your database. So now, what is the requirement from your database management system is, without modifying the existing structure, it should provide support for adding the new fields and adding the new relationship to the existing tables. So that is the idea behind your representing the complex relationship among the data. So next advantage is enforcing integrity constraint. So what is the meaning of the term constraint? A constraint means rule. So whenever you are going to store the data inside the database, it needs to satisfy certain condition. So we are going to refer that condition as the integrity constraint. So now, what is the requirement from your database management side is, your database management system should provide capability for defining and enforcing these constraints. So for example, one simple thing is, whenever you are having your simple thing is what? Your data type itself is considered as a constraint. So if I select number as the data type, then what does it imply? I cannot store a character. If I am going to supply a character as an input, it won't work. It will show you one error. So data type itself is an example for a constraint. And another thing is what? Along with the data type, you can specify the size. So what is the maximum size? Again, if you exceed the maximum size, it won't work. It will show you one error. So in addition to the data type and size, you can add a key field for the given database. So how to identify a record uniquely? So for that, for a table, I can identify one particular field as a key field. So which field is having unique value for all the records, that field will be designated as the key field for that particular table. So one example for a key is unique key or a primary key. Unique key or primary key. So if I make a particular field as a primary key, you cannot give null as an input, or you cannot give duplicate values for that particular field. So what is the requirement is, as a database designer, you need to identify the appropriate field for the primary key. See, suppose you are storing the student information, you are having student name and register number. You should not make student name as the primary key, because there is a chance for what? There is a chance for two students with the same name. But in most cases, your register number is going to be what? The register number is going to be unique. It won't be repeated, or it won't be reused. So you need to identify appropriate field, and you need to make that particular field as the primary key. And the next type of constraint is integrity constraint. That is your referential integrity. Now suppose you are having suppose if you are going to have a parent-child relationship, and if I want to, you are having two tables. One is the parent table and another one is the child table. So in the child table, if I want to insert a record, it should satisfy the what? It should have relationship to the parent table. So you don't have a value in the parent table, then I cannot insert a new record in the child table. So the relationship, you need to satisfy that relationship. So that we will discuss later. So referential, your foreign key is an example for your referential integrity. See, one simple example what I can say is, now you consider our university scenario. So according to our university rule, if you want to stay in a hostel, first you should be a student of Shastra, then only you can stay in hostel. Now suppose you imagine a situation like this. I am having two tables. In the first table, I have stored the information about the students. I am having another table called as hostel. So in the table hostel, I am storing the information about the hostelers. Information about the hostelers is available in the hostel table. Now what is the idea behind this referential integrity? So the thing is, I need a common field. So for these two tables, I need a common field. So what is the field I am going to use? I can use the register number. In the student table, my register number may be the primary key. In the hostel table, my register number will be the foreign key. So if I want to insert a record in the hostel table, what is the requirement? That register number should exist in the student table. Why? Because you cannot, if you are a student, so the thing is what? First, you need to get admission. At the time of admission itself, your information will be updated in the student table. If you are not a student of Shastra, you are not permitted to stay in Shastra hostel. So how to incorporate these type of constraints? For incorporating these type of constraints, so this constraint is an example for your referential integrity. So you can use foreign key. Okay, you can use foreign key to implement this referential integrity. Okay. So now what they are trying to say is, so these data type key, this referential integrity, what you can do is, you can incorporate all these constraints at the time of table creation itself. Okay, so apart from that, okay, so now even after incorporating these constraints, in some situation, what you need is, you need to check the data for completeness and the correctness. So now see, for example, now you consider this case. So as part of the student table, I have stored the grades. Now suppose you assume that only 3 grades came. So now the thing is what? So suppose you assume that for simplicity, you assume that for that grade only 3 input values are permitted. It may be A or B or C. So now what I can do is, I can incorporate a check constraint saying that only these 3 values are permitted for this particular field. So at the time of giving input, if the user supplies Z as an input, automatically your constraint will be violated. It won't work. It will show you an error. But now, by mistake, what are the permitted values for this field? A, B and C. So your actual value is going to be A. The actual grade secured by the student is going to be A. But by mistake or as a typographical error, if it is going to be, if the clerk enters it as a C, then in that case, automatically this error won't be detected. This value will get inserted. So these type of manual errors won't be what? These type of manual errors won't be detected by your constraints. So if there is a violation in the condition, that can be automatically detected. So what they are trying to say is you can minimize the errors by using these integrity, by using these various types of constraints. So this is an example for what? This is an example for business rules. So there is a violation in your business rule that you need to check manually, and you need to ensure the correctness and the completeness of the data in the database. So next advantage is permitting inferencing and action using rules and triggers. So this trigger is nothing but what? In the previous semester in Java, you have studied about the event handling. Okay. So if you map that event handling to your database scenario, it is called as a trigger. So what you can do is you can associate. So you are having a database. You can associate certain rules to the existing database. So by associating certain rules, what we are trying to achieve is, from the existing data, we want to infer some new information. We are checking whether it is possible to infer some new information by associating certain rules to the existing database. So these types of database are called as detective database systems. So now the thing is, what is the requirement is, see, suppose whenever, you have studied about what? Action event, item event and all. Okay. So when the user clicks the button, that event will be generated like that. So I want to monitor the water. I want to monitor the user interaction with the database. Or in other words, what I can say is, see, I want to, for safety purpose, I want to keep a backup copy. So whenever the user deletes a record from the table, I want to keep it in, I want to store the record in some other table. For that, what you can do is, you can create a trigger and you can associate that trigger to the table. So the thing is what? So what is the idea of trigger is, so trigger is nothing but a what? Trigger is nothing but a stored procedure. So whenever that event happens, the trigger will be executed. So suppose you are having a table, you have associated a delete trigger with this particular table, means whenever a record is deleted from the table, this trigger will get executed. Okay, so for certain actions, what you can do is, you can associate a procedure with your table also. So what is the difference is, if you are going to create a procedure, you need to invoke the procedure explicitly. If you are going to create a trigger, the trigger will get executed automatically. See, suppose at the end of the day, you want to check how many new records you have entered into the table. So you are having two options. One is you can implement this using a trigger or a stored procedure. Trigger means whenever user invokes the insert command, automatically I can do some count and I can display, or I can store that information in another table and I can perform a count operation. Stored procedure means then at the end of the day, what you have to do is, you have to invoke that procedure. So this is similar to your function. You need to invoke that function so that the code will get executed and it will give you the result. And finally, the last advantage is additional implication of using. What are the, apart from these 9 advantages, what are the additional advantages you are going to have? So one major advantage is your reduced application development time. See, once the database is configured perfectly, if you want to add some additional functionality, the time taken for adding the new functionality to the existing database is going to be very the time is going to be what? The time is going to be very less. And in another case, what they are saying is, see, if you compare this with the traditional file processing system, if the size of the file is becoming larger and larger, you need to equip each and every system with some you need to append the system with additional hardware, additional storage and all. Whereas in here, what we can do is, you are going to have entire thing in a same in a single location. So what is the disadvantage, or in other words, initially for designing and deploying a database, time taken from the scratch is going to be somewhat high. Okay, but once the database is configured properly, the time taken for further modification, the time taken to incorporate further modification is going to be very, very less. Another major advantage of your database system is you are going to have up-to-date information. If one user updates the data, immediately the other user can see the change that is immediately reflected. So you are not, so you are the thing is what? So every action will be immediately reflected. So this is with respect to infrastructure. Okay, that already I told you. If you want to increase the infrastructure by purchasing some hardware and software, you can buy some sophisticated system and you can implement it in a single location. And flexibility means you can change the structure. So it provides flexibility to change the structure and change the location. So these are the advantages of your database system. So to conclude, so now you may ask a question, sir, you have highlighted various advantages. Do you have any disadvantage? So already in the first class itself, I told you. Okay. So you are having certain applications where the use of database management system is not advisable or it is not suitable. So the major disadvantage with respect to your database management system is it is going to have what? It is going to have some unnecessary overhead and you will be having some additional cost. That is, if you see this point, you will be having high initial investment. Because you need to, everything is stored in a single location, you need a sophisticated hardware, sophisticated backup mechanism, all those things. So when compared to the traditional file processing system, in file processing system, you don't have concurrency module or you don't have recovery module, you don't have integrity module. So your DBMS is equipped with some additional modules. So if you take a DBMS, you are having some additional overhead in providing security, recovery, integrity, and the concurrency control. So when a DBMS may be unnecessary, see, if your application is going to be very, very simple and it is not going to change, and if you are going to have only a single user for that application, there is no need for multiple users. And if you are going you are going to have some stringent real-time requirements, the time need to be very, very less. You cannot store the data in the secondary storage device. You need to store the data in the primary memory. In that case, what you can do is you can store the entire thing in the form of a file. You can go for traditional file processing system. Okay, so the major difference is if your application is simple and if you are going to have only single user usage, then don't go for a database. For that, the initial investment and the cost will be higher when compared to your file processing system. So that's all with respect to your advantages and the disadvantages of database management system. Okay. So, thank you. So if you are having any doubt or if you need any clarification, you ask, I will explain.